spend my retirement talking about it. Thank you. Questions? Yes.
Yeah, I totally understand focusing on the students, but now that we're in this transition, we need to educate the families.
Absolutely, absolutely.
And
Communication is critical.
To even have that concept of energy. I mean,
That's right, and almost every textbook says, in biology says, the energy is in the food, and almost everybody talks about the energy in the chemical bonds, which is wrong. And so, yes, there's not just about the facts, but also about everything I just said. That if the parents don't understand why we're doing it differently from the way they learned it, they won't support it. So there's a lot of work to be done in communication about why it's based on evidence, why we know it will work better, why we think it's better for a wider range of students, and at the same time does not penalize the smartest students. There's a whole bias out there that if we do something that works for all students, you're going to hurt my kid who's a smart one. Right? Well, it's not true. If you do teach science this way, it also is better at reaching a wider range of students and giving them the base on which they could go as far as they want.
But you have a wide range of parents who have
That's true too.
a very wide range of backgrounds.
And a wide range of belief systems that they have.
Right.
Yes.
So
The communication problem is not trivial. I'm not trivializing it. You're absolutely right. But it's an important piece. As you work to change what you're doing in your school, you must also work to help the parents understand why you're doing what you're doing. Yes?
So just to clarify, there's another person here talked about students being behind in content level and standards. So would you say that it would be fair to say that, you know, say incoming sixth graders and they are kind of, they don't remember or they haven't been taught necessarily or are not fluent in fourth and fifth grade science standards. So the importance is that we teach them more of the methodologies and the bigger ideas and the connections than the actual core ideas and concepts until they get to that level.
You cannot teach science practices in a vacuum, right? You have to be practicing around a science idea. You have to be connecting across science ideas. So in fact, what you're doing is using the practices as tools to really move the conceptual understanding of the science forward. But you can start at the fifth grade level of science ideas. If you're teaching in this way, they'll move there much quicker than if you're just telling them, this is what you should know in fifth grade, and I'm building it on what you should have known in fourth grade, and I know you don't know it, but you still got to learn this. Right? The point is, what's intellectually engaging is much easier to learn. And so if you start at fifth grade level, even with students who haven't built that base, you can help them move there much quicker by doing it this way than if you just said, well, now I've got to do these standards, and they're a long way from where you were when you entered my classroom. Yes?
Small example that kind of builds on that. You mentioned that you'd like to see 4th through 6th grade math teachers talk about speed and density and so on. I teach physics at the early college level. The math teachers I talk to say, we still use feet and inches and gallons because that's what students are more familiar with and we don't want to intimidate them. Personally, I think it's the math teachers who are intimidated by the metric system. I'm just curious if you have an opinion on that.
It really doesn't matter which units you use to get the idea of units.
Yeah.
If they've got the idea, all of my kids are Spanish-English bilingual. They learn to read in, my grandkids, they learn to read in Spanish. Once they've got the idea of reading, it transferred pretty quickly to reading in English. So, and actually it's much easier in that order than the other order because English is much harder to learn to read and Spanish is a much more phonetic language. But, so, learn with whatever units you want, the importance of units, and that will then transfer to using your units relatively quickly, and the idea comes across pretty soon. I watch, again, using my granddaughter as an example, I have a granddaughter who moved from Guatemala to Mexico last year when she was just entering 4th grade. So her first math lesson in America was in a division unit, which she hadn't done division. It was feet and inches, inches to yards, feet and inches. There were ounces to pounds and ounces, all of which were units she'd never seen before. And yeah, it was a big struggle for the first few days, but very quickly she connected the things she knew, transferred over, and she could do it. So I think that the notion that we build whatever we're doing on what has come before, yeah, if the math teachers use feet and inches, start with feet and inches and then go to CGS units or MKS units or whichever ones you want to use. It's not critical that they've done exactly what you want them to do before, but it's critical that the conceptual base is being built to what you want them to do.
Okay, well, before we take the next question, sorry, we have another presenter, and then we're going to have a Q&A time for both of them.
Okay, that's a good idea.
Let's give Dr. Quinn a hand. Hold on to your questions, and we'll bring both of them up. So I want to introduce to you Crystal Howe. She's here from the San Diego County Office of Education, and she's going to do a quick response to Dr. Quinn, and then we're going to have time afterwards to do a question and answer for both of them. So thank you so much. And you're in the science division. Okay, thank you, Crystal.
So, I'm here for John Spiegel. He's the county office coordinator for science, and if I can find.
If you can shut my head.
So, I'm the pre coordinator. I help work with major educators, and some of these questions are coming up about worries in terms of how do we make this happen with the classroom, with the teachers, or cycling up K-12 is really where our focus is. So if you think about the size and the scope of San Diego County, we have 43 school districts that we're working with. That's 500,000 students, K-12. That's a huge mass of people. And when you think about teachers, that means we have teachers at every level of comfort with science, teachers who maybe haven't ever had to do science in their classrooms because they've had a push-in science resource teacher, all the way to people who have taught science in universities, worked with science doing research for their lives, and then came into teaching K-12 as sort of a second career. And that means that in a lot of this, similar to all of our different stakeholders, we're trying to meet people where they are, just like we do with our students, and really push them to a place where they can do the best work that they can and have the best understanding that they can with NGSS. So we've been working through the beginning pieces of this for a couple years, and the office that we're a part of, Learning and Leadership, we have this focus of really improving the quality of teaching and learning, and really thinking about the fact that it's not just the teaching, but also what's happening on the learning end, and that we should be thinking about our students and thinking about that student-centeredness in our classrooms. And NGSS is sort of a unique opportunity for us to start getting science back in at all levels and helping teachers to become comfortable with science and really want to push themselves and push their students in a way that can build this scaffolding and really create a robust science program for K-12. So these are some of the things that we've been doing for the last year or so, and they keep increasing and sort of ramping up and getting more rigorous as we go. This year we had our first year of what we call the Elementary Science Academy. We had districts from across the county participating, hundreds of teachers, K-5 participating, and they had a 9-day experience, 4 days in the summer, and then 5 days during the year where we are looking at science notebooking. We're looking at NGSS and really breaking it down. We are practicing how to do the practices and how to do the practices while doing the content and while doing the cross-cutting concepts so that nothing is separate. And we're really helping our science teachers at elementary level become more comfortable with how do I do all of this reading and writing and math that I've been pushed in is so important at elementary level, but I haven't done science because of it. How do we help them start to use science as a vehicle to do this English and math learning that they've been doing and really help their students come to love science and not lose their curiosity and their excitement about science before they get to middle and high school. So we have another cohort of that beginning this summer, and we're really looking forward to pushing more of those boundaries and really helping our teachers move forward. On the middle and high school side, we've done these NGSS 3 days where we help our teachers to look at some conceptual flows and how does NGSS look across a unit and not just as a one-day drop-in. And how does modeling look if I'm really influencing it across all of my work and not just saying, oh, today we're modeling, here's some Starbursts and some licorice and we're gonna make a model, okay? So really trying to use those things. We've developed this science leadership and professional development network where people who are leaders in science and leaders in districts can create these sort of teacher leads and mentor models where now you get the help that you need and the support that you need at the district level. And then also adding to that is this idea that we also are working with our informal educators. And so we're doing a lot of work with our nature educators and our museum educators and helping them to see what science is going to start looking like in the classroom and how they can support that with what they're doing out in the field and how what they're doing in the field can really support the classroom in a more integrated way instead of those days not showing what true science looks like, but we keep telling our kids, oh, you're going to meet a real scientist, and then they don't feel like they've seen it. But really helping that to be the same thing and for students to experience it in a well-rounded way. So we also have, as Dr. Quinn mentioned, some early implementation districts here. We have 3 of them in San Diego County, which means we have a critical mass of teachers that are beginning to do this K-8 and really thinking hard about what science should look like K-8. In February, we had a leadership conference around NGSS where we had 240 participants from Southern California. There was representing 35 districts from about Palm Springs down to us. And people who are just trying to figure out, from principals to people in district offices and county offices, how should this look and how can we really help science work well in our classrooms and with our students. And then just in the last 18 months, we've had over 2,000 educators coming through our programs to learn themselves and really start pushing themselves forward. So that stakeholder group of our educators is moving forward, and hopefully as we're educating each other, then we'll be able to move forward with our other stakeholder groups and really bring NGSS to a good place here in San Diego.
Crystal and Dr. Quinn to stay up here, and we'll spend some time with questions and answers. Okay, yes.
At High Tech High, they're teaching math and science together as one class. Do you recommend that?
I think it can work very well, as long as everybody's on board with how there's room for some time where you're really focused on math, and there's room for some time where you're really focused on developing a particular science idea, and there's a lot of time where you're working on both of them at once. I'm always afraid, I mean, I have seen too many times when efforts to integrate lose real content because they integrate superficially. So you have to really be very careful to design your curriculum so you're teaching both what you want to teach in math and what you want to teach in science. And then it can work wonderfully and be very, very powerful because it makes the math more meaningful to many students to see it in an applied context. And it makes the science more, using math to explain science phenomenon more meaningful because it's coming together better for the students.
In the yellow shirt in the back?
I'm curious if there's any information out about whether there'll be any change at the university level as to what they look for as far as a college path and science is required. There'll be any kind of change top down.
So I've actually talked to the committee at University of California that thinks about admission standards. And to some extent, they're waiting for the science framework to do some rethinking about it. I don't think there'll be any difference in the sense of there being 3 years of science required for college admission, and that's true for UC or for Cal State. Exactly